After the previous video ended, we wondered if the whole sensor proximity sensor was still working. So we plugged it into our little induction sensor setup we used earlier, and the surprising or not surprising thing is that it works now. Of course, it won't detect the aluminium, but it will detect my neatly magnetized pincers. It's about 6 to 7 millimeters away, and the LED lights up beautifully. But let's move on to the current topic. I won't keep you any longer. Let's move on to Gergő and MEMS sensors.
Hi there! In the following section, we will discuss sensors based on the movement of mechanical parts implemented at the microscale. These are referred to as MEMS, which stands for microelectromechanical systems. Examples of typical commonly used MEMS sensors are accelerometers and gyroscopic sensors. Gyroscopes and accelerometers are used where changes in position or orientation are needed to be tracked without using an external device, or in other words, we want to detect these with sensors on the moving object itself.
I think it's important to emphasize that even though we want to get information about the position of an object, most of the time we cannot use these sensors to get absolute values, only the relative changes compared to an initial state.
Mindig csak a kiindulási helyzettől vett relatív elmozdulásunkat tudjuk velük érzékelni.
You're absolutely right. Let me give you an example. If you lose the satellite signal while driving a car as you enter a tunnel, you can integrate the accelerometer's signal to replace the speed information. But because of errors in the accelerometer, the longer we stay in the tunnel, our estimated speed will differ from our actual speed. Since we don't have absolute information in the tunnel, our estimated speed won't match the real speed at all. We can mention lots of examples in our everyday lives where we are using MEMS accelerometers and gyroscopes. This is how the smartphone senses that you need to rotate the screen, and the navigation software senses which direction you are facing. Sensors like this are in game consoles, drones, and self-driving robots.
It may not surprise you that there are even several types of MEMS accelerometers. Now let's take a closer look at one type.
Indeed, the various topics on sensors are endless, so let's see how a capacitance-sensitive accelerometer works. We use a complex spring mass system in order to sense acceleration. We're talking about a microelectromechanical sensor, so it's pretty small, on the order of micrometers. The parts that can move slightly are formed on the layers of the integrated circuit. You can imagine this like putting two capacitors back to back and connecting one of their electrodes together. We hang this common electrode in such a way that its plane is perpendicular to the axis where we want to measure acceleration. When accelerated, a hung electrode behaves like a mass on a spring, bending in the opposite direction to the force causing the acceleration. Because of the bend, the distances between the inner and the two outer electrodes change, which results in a capacitance change in the two capacitors. This change in capacitance is converted into a voltage change by a signal processing circuit, which is also digitized by modern sensors. This digitized measurement can be read out via an interface, be it I2C or SPI. For example, here on my hand is this little black IC MEMS sensor. It contains an accelerometer, a gyroscope, and a magnetic compass sensor. Using all these sensors together, an inertial angle measurement can be achieved. As you can see, I have one of these sensors on each finger and the top of my palm. With this sensor configuration, my colleagues and I could digitize the angle of the fingers in space and return three-dimensional angular information with this system.
és háromdimenziós szöginformációkat tudunk visszaadni ezzel a rendszerrel. Említettem a kis
I mentioned in my little demo that this little sensor contains a gyroscope. A gyroscope is a sensor that converts angular velocity into an electrically measurable signal.
értelemben mérhető jellé. A MEMS gyroszkópok működése
MEMS gyroscopes utilize the Coriolis effect.
definíció szerint a Coriolis erő az inercia
By definition, the Coriolis force is an apparent deflection of the path of an object that moves within a rotating coordinate system.
erő. Gaspard Coriolis
It was first noted by the French mathematician Gaspard Coriolis in 1835.
az erő által okozott hatás számítása
Calculating the effect of the force is complicated because it is proportional to the angular velocity of the rotating coordinate system,
a mozgótest sebességével, a mozgótest sebességével,
the velocity of the object moving inside the rotating coordinate system,
valamint
the sign of the angle between the axis of rotation and the object's velocity vector, and the mass of the object. Its direction is perpendicular to the velocity vector of the object. In MEMS gyroscopes,
egy az
a small resonating mass on a silicon substrate is used to measure the Coriolis force.
rezgőtömeget használunk. A rezgőtömeg,
The mass can move in a certain direction,
amennyiben a rezgőmozgás
and if we rotate the substrate, a force is exerted proportional to the angular velocity and perpendicular to the resonating direction.
erő ébred. Ezt legkönnyebben úgy
We can imagine this easily if we think of the substrate rotating from under the mass
képzelni, a másik
while it is resonating between the two endpoints, moving the mass out of its original direction.
vagyis a tömeg kimozdul. A kimozdulás
The amount of movement can be detected with one of the methods we have already talked about when talking about proximity sensors or accelerometers, measuring change of capacitance. The Coriolis force creates a change in capacitance between the resonating mass and the side of the substrate. Without the Coriolis effect, the mass would not rotate.
ugyanis nem térne ki.
In the present figure, C1 and C2 would be the same, since the mass wouldn't rotate.
Mozog a tömeg. Még egy fontos dolgot érdemes meg.
There is another important thing about MEMS gyroscopes and accelerometers that should be mentioned. These two sensors are frequently integrated to one sensor, which gives us an integrated sensor with 6 degrees of freedom. Degrees of freedom might be unclear for you right now, so we will talk about what it means through two examples. In practice, I want to show you what the degree of freedom means.
Ez mit jelent? A gyakorlatban szeretném nektek megmutatni, hogy mit jelent a
You can see the sensor attached to my finger, and we have claimed that it can take 6 degrees of freedom measurements.
szabadságfokú mérést tud készíteni. Számoljuk most
Let's now calculate these 6 degrees of freedom together. I can move my finger along the x-axis, that's 1. Along the y-axis, that's 2. Along the z-axis, that's 3.
mentén az 3, valamint ugyanezen
I can also generate rotation along these three axes, angular velocity, that's 4, 5, and 6.
6. Azokat a rendszereket, amelyekben
Systems that have three axes and are capable of gyroscopic acceleration sensing are referred to as IMUs,
összefoglalni
or inertial measurement units.
mérőegységnek nevezünk.
Köszönjük szépen!
Thank you very much for the clear overview. From here on, it is up to the viewer to decide what physical quantities to measure, interface to a microcontroller, even with an MEMS sensor.
Akár MEMS szenzorokkal.
Bíztatok mindenkit a kísérletre.
I encourage everyone to experiment. I wish you good luck.
Tartsatok velünk
Stay tuned for the upcoming video because we're not out of useful sensors yet.
szenzorokból. Sziasztok!
Bye!
Bye!